All right, so today we are looking at day 2 of growth and decay, and we are specifically today going to look at compound interest and half-life, okay? Those are the two things. So this is going to be more of actual real-life applications, more so in depth, more active ones than what you've seen before, okay? So when looking at this, the first thing is we need to determine whether each of these functions represent a growth or a decay, and then determine the percentages. This is very similar to what we did yesterday. So we're starting off with a little review, so those of you who are absent, you can kind of see this here. When we decide if something was a growth or a decay, we have to look at the values that are inside our parentheses, okay? If that value is bigger than 1, it is a growth. If it is less than 1, it is a decay. Okay, so that's what we're going to look with first. So let's go through and label all of those for all 4 of these, okay? And remember, just like yesterday, I will label these 1, 2, 3, and 4, okay? So looking at number 1, is number 1 a growth or a decay? Growth, perfect. Number 2, decay. Number 3, it is a growth. And then number 4 would be a decay. Okay, now we knew that the last 2 were growth and decay, despite them not being decimals. Now, what I suggest is anytime you're given a fraction, if they're asking you if it's a growth or decay, make it a decimal. That's just my personal opinion, okay? Now, if you're just plugging it in, you don't have to do that, but that's what I would suggest to do. Now, to figure out what the percentage is of the growth or the decay, we have to do a little bit of math, all right? And here's kind of what we figured out. When it was a growth, you've got to think about it as a plus 1, or excuse me, let me back up. It's not a. When you think about it as a growth, you want to think about it as 1 plus the rate to equal whatever your decimal is. When you think about it as a decay, it was 1 minus the rate to equal whatever your decimal is. So what we did was we set it up as an algebra problem and just kind of figured it out. So to figure out this second one here, we know that we had 1 plus our rate to equal 1.682. Is everybody with me? Okay. Well, to figure out what your R value is, you have to get it by itself. So to do this, we're really just subtracting 1. Okay. Now, here, minus 1, we end up getting that R is 0.682. Now, that's what the rate is. That's what your R value is. To get it as a percentage, we have to multiply it by 100, and that gives our percentage here. So the percentage of growth for the first one is 68.2%.
Can we do round?
No. Need to be exact. You're getting in the point in your math careers where they want more exact answers than they do rounded answers. Okay? All right, let's look at B. B is very similar. As you look at it, you know that you had 1 minus whatever the rate is, and now you have 0.089, right? Well, here, just like before, subtract your 1s. Now, this one gets you kind of weird looking. You get negative R is equal to negative 0.911. Is that right? Will somebody double check me? I don't know if I did that right. Is that right? I did not do that right. Yeah. Somebody help me out. Oh, dang it. Wrong thing. I don't have my calculator. Will somebody please... It was 0.911, right?
Yeah, it said it's negative.
God.
You put 0.911.
The same thing.
Bennett. She said, oh. Oh, my bad.
It's the same thing. All right, and I had the negative there, you meanies. All right, so you get that. Now, obviously you don't want it negative, so you would divide both sides by -1. So you get that R is equal to 0.911. To make that into a percentage, you multiply it by 100, and you figure out that it is 91.1%. Okay? So you had a decay by 91.1%. All right? Now, same idea here with the next two. Now, what was the one thing that I suggested that you do? All right, so here what I suggested yesterday was to make these into a decimal. So what does 7/6 equal as a decimal? Okay, so here's what you're following, and I heard somebody say it. So 7/6 really equals 1 point what? Okay, 1 point. All right, now it's a repeating decimal. Here's what I would suggest. Round it to 3 decimal places. So it's going to end up being 1.167. Okay? So just like the previous one, you've got 1 plus your rate equals 1.167. And then you just solve it. So you subtract 1. You get R to be 0.167. You multiply that by 100, and you get out your percentage, which is 16.7%. Okay? So you had a growth of that. All right? Now, same idea with the next one. If you look at this B value, 2/3 is really 0 point, and it's going to be the same thing, 667 if you go to 3 decimal places. So same idea, same look. You had 1 minus R equals 0.667. So the first thing you want to do is subtract 1 from both sides. And you end up getting negative R is equal to what? Negative 0. It should be 3 decimal places. So since y'all refuse to help me, and y'all refuse to do any work, I'll grab my calculator. That's fine. I've passed this class before. So you get negative 0.333. Now, again, you want it to be positive. So you end up with R is equal to 0.333. But you got to multiply that by 100 to get your percentage, which was 33.3%. So you had a decrease of that. All right. So everybody should be good. Okay. I just saw in the directions it said round to the nearest 10th. Whatever.
I asked if we could round.
Yeah, to the 10th. You wanted to round it to a whole number. Okay. So 10th is 1 decimal place. All right. Now, there's kind of that info. All right. So that stuff's not going away. All right. What we're going to look at today, though, is more of a, hey, here's a specific equation. All right. So the first one is half-life. When you think about half-life, it literally says the name in there. It's a half-life. That means through the life cycle, it cuts it in half. So they give you the actual formula. It is y is equal to a times 0.5 to the t. What I want you to realize, this is very similar to what we learned yesterday, where it was y was equal to a times 1 minus r to the t. The only thing here is we're going ahead and telling you it's a half-life. We're not telling you, hey, you have to go 1 minus 0.5. All right? We're just going ahead and giving it to you. So this is a specific decay function. All right? It is very specific. All right? Now, the things that are represented here, and you can see A is the original amount. T is the number of half-lives in a given period. Okay? here's what you need to think about. To find this, you've basically got to do the large time period divided by the small time period. So what that means is when you look at this for a half-life, your T might not be exactly given to you. You might have to figure it out and solve for it and find it. All right? So let's look at this example down here. It says carbon-14 has a half-life of approximately 37 days. Find the amount of carbon-14 left from a 56 gram sample after 111 days. Now, let me first start about what has always struggled, or what students have always struggled with when they see this. Carbon-14 means that is the name of an element. You do not have to use the number 14. I have so many students, when they see this, they go, oh, well, it's got to be 14 of something. No, it's a science term, okay? Y'all are not, some of you might be in chemistry, some of you are not in chemistry yet. Chemistry, you talk about elements. Carbon-14 is a form of carbon. So all that is a name. That's the first thing I wanted to touch on, okay? Now, the second thing is they tell you that you are using a half-life. So we know we are going to use the formula that is above, and I'm going to rewrite it. Y is equal to A times 0.5 to the T. Okay? Now, here is where calculator and making sure you type things in correctly is going to benefit you so much. Let's go ahead and plug in what we know. Do we know the initial amount of carbon-14 that we had? Yes, we do. It says right here we have 56 grams. So you know your A value is going to be 56 times 0.5. Here is the new part. Figuring out your T value. Okay? Your T is the number of half-lives in a given period. So what you've got to look at is the total amount of days that you were given divided by the number of days that make a half-life, or the number of times that make a period. So here we know our sample was 111 days, but a half-life is approximately 37 days. So it's really 111 divided by 37. And if you actually work out that math, you figure out that your T value is 3. So that means when you plug it into your formula, you plug in a 3. You don't plug in a 37. You don't plug in a 111. The number of half-lives that happen are actually 3. And then it's exactly what we were doing before. All right? What I would do in my calculator is go 0.5 raised to the third power. Okay, and I'll write this one just to show you the example. So that means we're left with 56 times 0.125. And then I'll multiply that by 56. And you get out 7. So after 111 days, we would have 7 grams left. Now, let's talk about something and make sure we're all on the same page. With half-life, am I ever going to have something that is bigger than my original sample? No. It is a special type of decay function. So that means it has to get smaller. Everybody good with that? All right. So let's continue on. Okay. Well, I guess real quick, I know I changed the slide. Do we have any questions on half-life? Do y'all kind of understand what that's saying? Okay. Do you want me to give you like a small example that might help it make more sense? All right. So say you had 8 grams of something. What a half-life says is after the half-life is up, it's cut in half. So if I had 8 grams after the first half-life, how many would I have left? 4. Okay. Well, then I do another half-life. Do I take away 4? No, you just cut your new number in half. So 4 would become 2. Then another half-life. After my third half-life, I'd have 1. Then I cut that in half. So after my fourth half-life, I'd have 0.5 or half. Okay, and it works around that way. Okay? Now, looking at this next thing here. This is compound interest rate. This formula is a little bit more in depth. I'm going to give you these formulas, so you don't have to memorize them right now. But let's look and see what they're actually talking about here. All right, so as we look at a compound interest, you notice each letter is represented by something. Y is the amount total. A is the initial amount that you invested. Okay? Then you've got inside your parentheses 1 plus R divided by N, where R is the interest rate as a decimal. So we talked about that. We can't plug in interest rate as percentages. Okay? Then N is the number of times it's compounded per year. All right? And T is the time in years. Now, T is the time in years. So that's easy for us to figure out, right? R is our interest rate, A is initial amount, so on and so forth. The part that is new here is the number of times that something is compounded. All right? It says it is the number of times compounded per year. So when you think about that, that is how many times they actually look at it and compound your interest and add it on there. So, if something is compounded annually means per year, one time. So, if they tell you something is annually compounded, then that means your end value would be 1. All right? If they say it is semi-annually, okay? Think about semi-annual sales that some of your stores that you like to shop at have. Those are sales that happen 2 times in a year. Semi, okay? So that end value would be 2. I'm telling you all this because you're going to be given problems where you have to figure out what your end value is. All right? If they say something is done quarterly, well, how many quarters are in a year? 4. It's the same amount that are in a dollar. All right? There are 4 quarters. So quarterly, your end value would be 4. What if I said it was compounded monthly? How many months are in a year? 12. What if it was compounded bi-monthly? Well, that means it's compounded 2 times a month. How many months are in a year? 12. So this would be 24. Because everything is based on the year and then how it applies to the year. Okay? What about weekly? No. There's 7 days in a week. But remember, we're trying to figure out weekly. So how many weeks are in a year? 52. That would be correct. It's all based on a year. Okay? So the next one is, hey, they want to compound it daily. Well, how many days are in a year? 365. So you see how all of these numbers are how they are affected by a year. Okay? All right. Now, this chart's going to be very useful. I would have it filled out. I would have it available for Friday. Just a thought. I'm not very smart, but just a thought. All right. So, there's all your stuff here. So, let's take a look at one of these examples. Okay, so here it says the money bank is offering me 5.5% interest rate compounded weekly, and I invest $100,000. How much will I have in 3 years? So we know we are using that formula up top, right? Okay, we are. So we're using this formula, y is equal to a times 1 plus r over n raised to the nt power. Now, we're going to have to do a little bit of math to figure some of this out and get it going. But we'll be able to do a lot of it in our calculator as long as you can enter it correctly. So, looking here, let's figure out some of our stuff. What is our A value? What is our initial amount that we're investing? $100,000. So we know we're putting that in there. Now, the next thing we're going to do is plug in the rest of our terms. Well, we know that we're going to have a 1 plus. Well, what is the R value here? Well, we know our percentage was 5.5. But to make that into a decimal, we got to take 5.5 and divide it by 100, which would give us 0.055. So the top part in here is 0.055. Is anybody lost yet? All I'm doing is taking the stuff that I need that was given to me and plugging it in. Now, the next part is our N value, which is the number of times it is compounded per year. Well, they said that our interest rate would be compounded weekly. So you got to think, if it's compounded weekly, how many weeks are in a year? 52. So in the bottom part of our fraction, it would be a 52. Now, here's the important part. That is not the only place that the N value shows up. It shows up in the bottom of your fraction, but it also shows up in the exponent. Yeah. So in your exponent, you're going to end up with 52 again for your N value, times, they want to know after how much time has passed. Well, how many years are going to be passing that we compound it 52 times? 3 years. So, look at that wild and crazy equation. Now, I know you can't see my calculator, so I'm going to list out right here the way that I plug it in to solve it. Are y'all okay with that? Okay. The first thing I'm going to do, step 1, so this is calc steps. Please pay attention and quit talking. Here are the steps that I'm going to follow for this. The first step is I'm going to take my R divided by N value and get its answer. So what that means here is I'm going to go 0.055 and divide it by 52 and figure out what it's equal to. That is the first thing I'm going to do. Y'all with me? Step 2, I'm going to take that answer and add 1. Okay? So in my calculator right now, I went 0.055 divided by 52, and I got out 0.0010576923. Okay? And all I'm going to do next is just go plus 1. So it says answer plus 1. And I get out the same thing I had before with just a 1 in the front. Okay? Then I'm going to hit the caret button. Okay? So I'm going to go caret, parentheses, and I'm going to do whatever my exponent is, which this case is 52 times 3. Okay? So caret, parentheses, 52 times 3. And notice I'm doing that. So what this looks like, okay, what this example looks like is it says answer, caret, 52 times 3 in my calculator. The caret just puts it in the exponent, okay? That's what it looks like. And then I press enter. And I get out a new number. It takes me to 1.179290282. Okay? And then the last thing I've got to do to get my final answer is take that answer and multiply it by my A value. So in this case, it would be the answer times 100,000. And press enter. And when I do that, I get out my actual answer, which here is $117,929.03. What I need y'all to talk to me about right now, was anybody lost from the steps that I just did? Okay. Where did I lose you? Talk to me.
The carrot part.
Okay. So the carrot part up here, once I added the 1 to my answer. When I hit the carrot part, what I'm doing at this point is trying to take everything that I just found inside my parentheses and raise it to this power. Okay? So all I really did was just have my answer, and then I pressed the caret on my calculator because my calculator doesn't have an exponent button. Your calculator might have the X to the blank button or something like that, where you can press it and it automatically makes it go to an exponent. Mine doesn't have that, so I have to use the caret. Okay? I can come around and show you. I just don't have a way to show you on this document camera. What I can do is, I got a document camera. I'll videotape me working out a problem and post that as well. But that's really all I'm doing, and I'll get with you separate and show you here in a second. But for digital learners, I can do that. But all it is simplifying that answer, trying to work it down to get it into a part where you can do it. But it's all calculator work. The issue is you've got to enter it in your calculator correctly, or it's not going to work out. Questions? All right. Now, what we are going to do is have some time to work some problems. I am going to put you in a difficult spot. I want you to work on the next 3 examples on your own right now. If nothing else, I want you to write the correct formula on each one, and then we'll work them all out after lunch. We just don't have time to get them all worked right now, so I'm going to wait and push it to after lunch, and then you can have some time to practice. Okay? Okay, so I'm asking you to push yourself a little bit here. All right, ready, set, go. All right, so looking at example number 1, it says find the final amount of a $500 investment after 8 years at a 7% interest rate compounded quarterly. So, step 1, remember, it is this formula. Y is equal to A times 1 plus R over N raised to the NT powers. Okay, well, we know looking at this, our initial investment was $500. 1 plus the rate. Well, we know R was 7%. So 7 divided by 100.
0.07.
Yep. So you end up getting 0.07 divided by your N value, compounded quarterly. Yeah, I heard it. Quarterly, there are 4 quarters in a year. So it is divided by 4. Okay. Now, this is going to be raised to the N times T. So we know N was 4, but then they tell us exactly. They tell us after 8 years. So the T value would be 8. All right. Now, how this works, I would go in my calculator. I'm gonna write out the exact steps. 0.07 divided by 4, and I get out my answer. So if I'm in my calculator, 0.07 divided by 4. Okay? I'm going to write it out because this decimal's not bad. That gives me 0.0175. Okay? So there is step 1. Step 2, I take my answer. This is exactly what it looks like in my calculator. Plus 1. And I press enter. This is what I get out. Y'all okay?
Yes.
Step 3, this is exactly what my calculator looks like. I type in answer, the caret button, and then I go parentheses, 4 times 8. That is exactly what it looks like. This is the answer that I get out. Okay?
Man.
Is that what y'all got? Okay. Okay. All right. Now, at this point, I'm going to take that answer and just go times. So step 4, it says again answer, and then I'm going to go times 500. Okay. And once that, it gives me out my final answer, which was 871.1067461. And that is what it would be. Now, the thing here is I know that I need to just round to 2 decimal places. So it would really be 871.11. So if I put in $500, after 8 years at a 7% interest compounded quarterly, that $500 would be $871.11. Okay? And that's just the money sitting there doing nothing. Okay? All right. So there's that. We got 2 more examples after lunch. All right. Here's these last 2 examples. All right. The next one is a half-life problem. Right? It says the half-life of oxygen 14 is 71 seconds. How much of 1,250 gram sample will be left after 319.5 seconds? Okay. The thing to remember for half-life, y is equal to a 0.5 to your t. Okay. In here, your initial value was 1,250. 0.5. The issue here is your t value. Okay, so remember, it is big divided by small is the easiest way to look at this. So there were 319.5 seconds they want to know, but we know a half-life was 71. Okay, so if you go 319.5 divided by 71, what do you get out? I know the answer because I typed it in. You should get out 4.5. Okay? So that means your t value here is really 4.5. Okay? So as I would do here, I would go 0.5 in parentheses raised to the 4.5 power. Okay? And then I would multiply that answer by 1,250. And you should get out 55.24 grams. Okay? Always, 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 unless specified. I always like to go 2 decimals. Okay? 2 decimals unless otherwise specified. Okay? Questions on that? That example fits a little bit more to what we did yesterday. It's just using the half-life thing to figure out your t value.